We're going to be looking at rearranging, or you may sometimes hear it be called transposing equations. So that's kind of, if you've got some sort of algebraic expression, you're just kind of trying to rearrange that expression to make one of the variables the subject. Before we sort of get into that, we do need to know the basics of substituting values into a formula. So let's say you've got the familiar equation for the area of a circle. So let's say the area is pi times r squared. If we had the radius of a circle was equal to 2, we just need to substitute 2 in for that r. So our formula becomes area is equal to pi times 2 squared. We get pi times 4, and if we put that in our calculators, we get the area of that circle would be around 12.6, and whatever the units were, let's say they were meters squared. All right, let's say we had a more abstract equation. Let's say we had y is equal to 3x plus 2z minus 6, and we had x was equal to 3 and z is equal to 1. We just need to substitute 3 in for wherever there's an x and substitute 1 for wherever there's a z. So I'm going to rewrite the equation. Alright, so you can see wherever there was the x, I've written 3, and I like to put it in brackets. That kind of shows me that I've just put 3 in for the x place. And often in algebra, just like here, there's a hidden sort of multiply sign here because the 3 is on the outside of the brackets. So we know 3 times 3 is 9 plus 2 minus 6, and if I trust myself to do maths in my head, y should be 5. Now, we can do stuff like this because we're used to using BODMAS or BIMDAS, whatever sort of acronym you've used before. So we've all heard of this before. Sometimes it might be slightly different, like BODMAS. I like BIMDAS in this situation. So when you're calculating or solving an expression, you want to first do the brackets, then the indices, multiplication, division, addition, subtraction. So that's what we do when we're calculating something. When we're transposing or rearranging an equation, however, you actually need to work backwards. So we'll do some examples to show you what I mean. Let's first start with the area of a circle, for example, because we used that before. We had a is equal to pi r squared. So let's say you knew what the area of the circle was, and you want to work backwards to find out what the radius is. So what you might want to do is you want to rearrange this equation so that it shows r is equal to something. So that's what, if you were to say you have this equation and rearrange to make r the subject, making r the subject is having r at the front on its own. So you're trying to r is sort of buried in this equation, and you want to pull it out on its own at the front. So let's see if we can use this sort of backwards BIMDAS to work this out. Looking at this side of the equation, there's no subtraction or addition, so we don't need to worry about that. There's no division, but there is a multiplication. We have pi multiplied by the term r squared. So we want to sort that multiplication out first. The way we can do that is if we divide both sides of the equation by pi, what will happen is they cancel out on this side. And our equation becomes a over pi is equal to r squared. All right, now we want, after multiplication, we've only got indices to worry about. And we do have an index. We have r that is squared. So what we can do is, if we square root both sides, if I square root that side, square rooting r squared, they will cancel each other out. And I also need to square root the entire equation on this side. So what I end up with is the square root of a over pi is equal to r. And you can see that we've sort of extracted r from this equation to make it the subject. Let's try a few more examples and see if this keeps on working. So we've got another equation. S is equal to n over 2 multiplied by a plus l in brackets. And I want to make L the subject. So working through this, you might think we do have an addition here, but we've got to notice that it's inside brackets. So we're not going to get to this bracket part until the very end. We have to go through everything else first. So looking outside the brackets, we don't have anything that's added on, but we do have the fraction n over 2 that is multiplied by this brackets. There's a couple of ways we can approach this. Because we have the whole fraction n over 2 that is multiplied by the brackets, we could divide each side by the fraction n over 2, but dividing by fractions is kind of annoying. So instead, one way you could write this is you could, to sort of see what's going on, you could choose to rewrite the equation like this. So these equations are exactly the same. If you have n over 2 and it's multiplied by a number, say a plus l, that can sort of jump up to the denominator. So we can rewrite this as n times a plus l, that whole thing divided by 2. And now we can sort of see, all right, going down here, the first thing we want to get rid of is this divide by 2. To do that, if I multiply both sides by 2, what that will do is these 2's will cancel out. I'm left with 2s on the left-hand side is equal to n multiplied by a plus l. All right, next thing we've got is we've got a multiplication by n. So I want to divide both sides by n now. These n's will cancel out. So I've got 2s all over n is equal to a plus l. All right, now we've got to only our brackets. So I didn't really need to draw the brackets in there, but I just wanted to keep doing it for consistency. So now the only thing that's left is we want to get rid of this plus a. So we do the opposite of plus a. We subtract a from there, and I'll subtract a from that one, because that plus a and minus a will cancel out. So we're left with 2s over n minus a. Note that the minus a does not go in the numerator of this fraction. It's completely separate. And that is equal to L. Now we've got minus xy minus z is equal to xy plus z. And we want to make x the subject. So this one's a bit different. Because we want to have x is equal to something, there's only going to be one x. There's not going to be any x's on this side of the equation. But you can notice we actually have an x on both sides here. So we need to try to join them together to try to make x on its own before we can start sort of rearranging everything else. So what I'm going to do is I'm going to bring this xy over to the other side first to see if we can simplify it. What I can do is if I add xy to each side of the equation, this negative xy will cancel out with this positive xy, and it's just adding xy to this side. So I'm going to end up with negative z is equal to xy plus z plus my xy on the back. Now I can actually notice that xy and xy are like terms. You might remember from year 7 and 8 algebra that like terms are terms that contain the same variables and they're raised to the same powers. So I can join them together. Got negative z is equal to 2xy plus z. Alright, perfect. Now we can start rearranging everything because we've only got one x in here. Now there's only one x in the entire equation. We can start working through our steps to try to isolate this x on its own. The first thing we have is an addition. We've got a plus z on the end here. So to get rid of that, I'm going to subtract z from each side. Z minus z. These are like terms, so I can immediately join them together to make it negative 2z equals 2xy, where the plus z and negative z cancel each other out. Next, we've got a multiplication. We've got a multiplication of 2y. Remember, we can sort of rewrite this bit as 2y times x. They're the same thing. Just like, you could have 5 times 3 is the same as 3 times 5, for example. It doesn't matter what order they're in. So because 2xy are all multiplied, it's the same as 2y times x. So in order to fix this up, I'm going to divide both sides by 2y. This 2y term and this 2y term will cancel out. And I'm left with negative 2z all over 2y is equal to x. And I can actually simplify this fraction. I notice that the numerator and denominator have a common factor of 2. So they actually cancel each other out, these 2's. And in the most simple form, I've got negative z over y is equal to x. We've got a slightly more complicated one here, but it only contains constants. We don't have any other variables. The only variable we have here is x. So if I've done everything correctly, actually I just made this equation up, but hopefully we should get a value for x, an actual number. And I've also written our little SADMIB acronym over here so we remember the order. So we want to extract x. It's kind of buried deep in this equation. We need to work through our steps to get it on its own. The first thing we see is we've got an addition out here. So to reverse that addition, we can subtract 17 from each side. Subtracting 17 will cancel out this add 17. And in my calculator, 200 minus 17 is 183. So I'll rewrite our equation. Got x plus 3 all over 2 to the power of 4 is equal to 183. The next thing we do have some addition and division here, but they're inside brackets. So we need to do the index first before we have a look at the brackets. We need to get rid of this power of 4. To do that, we need to find the fourth power of each side. If we have something to the power of 4, we need to find the fourth power. So this sort of root fourth power will cancel out the power of 4 there. And I need to find out what's the fourth root of 183. It's 3.68. We'll go with that, 3.68. So we've got x plus 3 all over 2 is equal to 3.68. So we've gotten rid of that. I could write the brackets, but we don't really need them now because once we got rid of that power of 4, we've just got this fraction is equal to 3.68. The first thing I see now that we've sorted out the index and we've relieved the brackets, we can go back to the top. The first thing we see is a division. You might say there's an addition there, but because the entire x plus 3 is all divided, the whole thing is divided by 2, that's the first thing we need to get rid of. To get rid of the divide by 2, we multiply by 2 on each side. $7.36, sorry. So divide by 2 cancels out those 2's. We have x plus 3 is equal to 7.36. Now we can just subtract 3 from each side. This add and subtract 3 will cancel out. We have x is equal to 10.36. Now we can actually, let's see if we've done that correctly. We can type in 10.36 for x there and complete the equation, and let's see if I've done that right. So that should equal almost 200. Nope. Clearly, I've made a mistake. That's my bad. That's a minus 3. That should be 4. 4.36. So let's change that. Oh, fingers crossed. There we go. The reason that's got a 0.4 there is because obviously 3.68 is not exactly the 4th root of 183. It's close though. So that's a bit of a rounding error. So essentially the takeaway from this video is that if you know BODMAS, or in this case BIMDAS, you also know SAD-MIB. It's our new acronym for transposing equations. And the more you do this, the better you'll get. So practice is key with this one.